Okay, so let's have a look at compound interest. You're probably aware of the fact that compound interest, or that interest itself, I should say, is what people earn on their investments when they put money in the bank or other financial instruments, and then it's also what people pay when they borrow money to buy a car or get a mortgage or something like that. So basically, it's just the cost of borrowing money. So compound interest is where interest, instead of waiting until the end of the year for an annual interest rate, you can make stops along the way, so to speak, at various times and add the money that's already been earned in interest as a percentage of the principal, which is the amount we're investing, and add it in before waiting all the way until the end of the year. So we've got a lot of terminology here. We've got the word principal, and that just means the amount of money that you're investing. That's sort of like the initial value or initial amount for those population problems we looked at, or the amount of kilograms of some radioactive element that we looked at with decay. And then the interest rate here, that's just the normal interest rate like we saw as a percentage growth or decline rate. What's different and new in this case is the N means the number of compounding periods per year. So it could be annually or quarterly, monthly, weekly, daily. Now I didn't put T down here, but T is just time in years. It'll always be T for time. It'll always be years. And so this is not much different from the problems we've done. Let me make that a little bigger so you can see it. Y was equal to A times B to the X, where A was the original amount, the initial population, let's say, or the amount of radioactive such and such that was decaying. And then B became our multiplier, which was just, 100% plus whatever that rate was. Well, it's very similar here. It's just that because the rate may not be an annualized rate, well, R is an annualized rate, but based on the compounding time, you're not earning it for a full year, you're earning it for that smaller period of time, whether it's monthly, weekly, or whatever. So we have to account for that, and then we actually account for that up here in the exponent when we do N times T. So it looks pretty complex. It's actually very much, it's just this right here applied to a monetary situation. So let's look at. So in this case, as you can see, I've already jotted down that the principal is 1,000. And the interest rate is 9%. It's compounded annually, so in this case, N is just 1. And then what I didn't put is the NT, so that's 1 times 4. So really this whole thing is just $1,000 times 1.09 to the 4th power. It's basically what this problem is. And so when I run that calculation on my calculator, 1,000 times 1.09 raised to the 4th power, I get a final amount of $1,411.58. Now, my calculator tells me it's actually 161, but remember, we're always going to round to the nearest cent, and so the spot to the right of the pennies place is definitely not 5 or above. And so we'll say 1411.58. And Ixl will tell us how smart we are. All right, this one's a little bit more interesting. We've got more features going on. It's not annual anymore. So Devin opened a savings account and deposited $600. All right, so there's my P. The account earns 3% interest. Well, there's our interest rate. Remember, expressed as a decimal. Compounded quarterly, it tells me, which means N is 4. And she wants to use the money to buy a new bicycle in 3 years. So T is 3 years. So we've got P, R, N, and T. All we don't know is the final value, so that means for our formula, it says A equals P times 1 plus R over N to the NT. For our case, that's 600 times 1 plus 0.03 over 4. sorry, this is kind of ugly, raised to the, now if you're going to use your calculator, you want to put this in parentheses. I would advise, if the numbers are simple, just doing the math in your head. Quarterly is 4, t is 3, 4 times 3, so it's just as easy to figure out that that number right there is 12. And type this into your calculator. See, what you want to do is what we're going to type in is 600. We're going to use parentheses, 1 plus 0.03 over 4. Notice it's not 1.03 over 4. It's 1 plus this rational expression of 0.03 over 4, all raised to the 12th power. And so I'm going to do that for you right now. 600 times parentheses 1 plus 0.03 divided by 4. Now, if you're using a scientific calculator, you don't need to put this in parentheses because your calculator will understand order of operations. But be careful. If you're doing it with a very simple calculator, you're going to want to find out what this number is because otherwise it's not going to follow order of operations. I'm using a scientific graphing calculator, so I'm not worried about that. So the answer I get is $656 and 2.2841. So, of course, as always, we're going to round to the nearest cent. So to the nearest cent, that is correct, 656.28, which I would type in right there. All right, here we go. Brennan and Kimberly deposit $700 into a savings account that earns 13% interest, compounded monthly, and they want to use the money in the account to go on a trip in 3 years. So we've just gotten all the information we need. There's P, there's R, here's T, and monthly means that N is 12. So let's look at this formula right here. Let's just recreate that. So A, the final amount of our investment, is $700 times 1 plus 0.13 over 12 to the, in parentheses, 12 times 3. And again, we know that's 36, but, just in case you don't, or you want to be, some people like to be very methodical about just using the parentheses. So when I run this number, $700 times parentheses 1 plus 0.03 divided by 12, all raised to the 36th power. Again, be really careful if you're going to be using a calculator here. You've got to make sure that if you're not using a scientific calculator that you would put that in parentheses or just figure out what it is and add it to 1. Because if you don't, you might get crazy answers. 765.8359. Now, let's stop and is that reasonable? Is it reasonable to think I could start with $700, invest it, and after 3 years have roughly $765? Yeah, it is reasonable because 13% is pretty high. And even though I'm only doing it for 3 years, it's getting compounded every month. And so our final answer, when I use my amazing rounding skill that you guys all have, is to the nearest penny, $765.84 because of that 5. Last one. So it says Sophia earned money last year doing odd jobs last summer, and put in a savings account that earns 2% interest, 9 years, $300 in the account. Now this one is a little bit different in the sense that what we have is A. And what they're asking us to say, how much did Sophia, what they want to know is what's P. So this isn't really too complicated. All we have to do is just be careful about the fact that we're not asked for the final amount. We're asked for the starting amount. We've got the compounding arrangement, which is quarterly. N is 4. R is 0.02. And we know that T was 9 because it was 9 years. So what we don't know, and we actually do know what A is, it's 300. So what we don't know is P. Kind of what I said down here. So let's set this up. So if I use my formula, the final amount of an investment as a function of time, is the principal times 1 plus the rate over the number of times per year the compounding takes place, all raised to the product of n and t. That means that 300 equals p times 1 plus 0.02 over 4 raised to the 4 times 9 n times t. So 300 equals p times 1 plus 0.02 over 4 to the 36. Now this problem looks pretty scary, but when you think about it, the only part we don't know is this. Sorry, wrong tool. This is the only thing we don't know. And we can figure this thing out pretty easily with a calculator. So then this will be a one-step equation in which we take p times this, whatever that number is, equals 300. So then we'll divide whatever that number is on both sides to find the amount of the principal. So if I just want to figure out what this right here is, I'm going to type that amount literally into my calculator. I'm going to say 1, I'm going to use parentheses. First 1 plus 0.02 divided by 4 to the 36th power. That's going to give me that this principle basically was essentially, with the compounding arrangement and everything else, had an annualized interest rate of approximately 19 point, about 20%, because when I do the math here, I get something that goes on like that. So really that means that the $300, the principal, was basically the same thing as 1.20% with rounding. Now I could wait to round until the very end, and sometimes that's a good thing to do, but I think in our case, I don't know if Ixl is going to pick up on a difference there. I'm not sure if it will. We'll have to look. You might want to try it both ways, but essentially what I would do at this point is I would just divide 300 by 1.2 and get my principal. 300 divided by 1.20, and that means that the investment initially was $250. Looks a lot different, looks a lot more complicated, but once you understand what this formula is, it just means we're missing not A, but P, but we can use some pretty basic math to get our answer. Do your best. I'm sure you guys will be fine. Let me know if you need help.